For decades, there was this organ tucked away in our chests that scientists basically wrote off after childhood. They thought it shriveled up, became useless, and was just kind of there. But it turns out this forgotten organ might actually be a critical player in how long we live and how healthy we stay, far beyond our teenage years.
It's such a classic things I know nothing about scenario, isn't it? Something that was dismissed as irrelevant only for cutting edge research to suddenly reveal it's actually pulling some serious strings behind the scenes. And when we say serious strings, we're talking about our fundamental health and lifespan, which is pretty mind blowing for something we hardly ever think about.
Absolutely. Today we're diving into the thymus, which, as you said, was largely considered a vestigial organ in adults. But a groundbreaking 2026 Nature study has completely upended that view, suggesting that the health of your thymus is a powerful predictor of your risk for cardiovascular disease, cancer, and overall mortality. It's a huge shift in medical understanding.
I'm already fascinated. So, for those of us who, like me, probably haven't thought about our thymus since a high school biology class, if even then, can you quickly remind us what this organ actually does? Because I vaguely recall something about the immune system, but the details are definitely hazy after all these years.
Great question, and it's essential for understanding why this research is so significant. The thymus is a small, specialized organ located behind your sternum and between your lungs. Its primary role, especially during childhood and adolescence, is to produce and mature T cells. These aren't just any cells. T cells are a crucial type of white blood cell, essentially the highly specialized scout cells of your adaptive immune system.
So, they're like the elite forces of our immune system, specifically trained to identify and neutralize threats. I imagine them as highly skilled detectives, really good at recognizing the bad guys that our body encounters for the first time, which sounds incredibly important for staying healthy.
That's a perfect analogy, Maya. They are indeed highly skilled detectives. When you're young, your thymus is bustling, churning out a diverse army of T cells, each trained to recognize a specific pathogen or abnormal cell. This diversity is key because it equips your immune system to respond to a vast array of new threats, from novel viruses to emerging cancer cells. As we age, however, the thymus naturally undergoes a process called thymic involution.
Ah, involution. That's the shrinking part, right? The reason why it was thought to be useless. So, what exactly happens during involution, and why did medical science previously assume that once it started shrinking, its job was essentially done and we could forget about it?
Exactly.
Thymic involution means the organ gradually shrinks and its functional tissue is progressively replaced by fatty tissue, typically starting around puberty. The prevailing wisdom was that by adulthood we've built up enough memory T cells from past infections and vaccinations that the continuous production of new, naive T cells from the thymus becomes less critical. It was seen as a developmental organ, crucial for setting up the immune system in youth, but then becoming largely redundant.
That makes a certain kind of logical sense. I suppose your body has already created its initial army, so why keep the factory running at full capacity? But clearly that assumption was profoundly mistaken given what this new research is telling us. So how did this 2026 Nature study come about, and what was the big revelation that made everyone rethink the thymus?
The revelation came from a series of interconnected studies, primarily led by Harvard-affiliated researchers at Mass General Brigham and Dana-Farber Cancer Institute, with corresponding author Hugo Ertz. What they did was incredibly clever. They leveraged artificial intelligence to analyze routine computed tomography or CT scans of tens of thousands of adults. This AI developed a thymic health score based on the organ's size, shape, and composition, essentially looking for signs of a more active, less involuted thymus.
That's fascinating. Using AI to essentially read something in existing scans that doctors might have overlooked or not known how to interpret in this context is brilliant. So they developed this score, and then what did they track these people over time to see if their thymic health correlated with their actual health outcomes?
Precisely. They investigated data from two massive prospective cohorts, the National Lung Screening Trial, or NLST, which included over 27,000 participants, and the Framingham Heart Study, or FHS, with over 2,500 participants. These are huge long-term studies, making the findings incredibly robust. They then tracked these individuals over an average of a 12-year follow-up period, comparing outcomes between those with high versus low thymic health scores.
Okay, so this wasn't some small scale, short term observation. We're talking about tens of thousands of people followed for over a decade. That lends a lot of weight to the findings right away. So, Alex, what were the headline results? What did they discover about the link between thymic health and, well, everything?
The results were truly astounding, Maya, and paint a very clear picture. Let's start with overall longevity and all-cause mortality. Individuals with higher thymic health scores consistently exhibited significantly better survival outcomes. Over that 12-year follow-up period, participants with a healthy thymus were approximately 50% less likely to die from all causes compared to those with poor thymic health.
50% less likely to die from anything. That's not just a marginal improvement, that's an absolutely massive reduction in risk. To put that into perspective, if you have a 10% chance of dying from all causes over a decade, a 50% reduction means your chance drops to 5%. That's like mind-bogglingly significant. It makes you wonder what else is going on with people who maintain better thymic function.
It really is substantial. To give you some more concrete numbers from the study, in the high thymic health group, the mortality rate over 12 years was 13.4%, whereas in the low thymic health group, it jumped to 25.5%. And crucially, these associations remained highly significant even after the researchers adjusted for other major risk factors like age, sex, smoking status, and any pre-existing history of illness. This suggests the thymus isn't just a proxy for general good health, but an independent predictor.
Wow. That adjustment for confounders is critical because it strengthens the argument that the thymus itself is playing a direct role, or at least reflecting a core aspect of health that impacts longevity. So, beyond just all-cause mortality, did they break down the risks for specific diseases that we usually associate with aging, like heart disease or cancer?
They absolutely did, and the findings are equally compelling. Let's talk about cardiovascular disease first, which is a leading cause of death globally. The study found that high thymic health was significantly associated with a substantially lower risk of cardiovascular mortality. Participants with a healthier thymus had up to a 63% lower risk of cardiovascular death in the NLST cohort.
63% lower risk of cardiovascular death. That's enormous. We talk about diet, exercise, and genetics for heart health. But now we have to add thymus health to that list. It really puts a new spin on immune system function, which we don't always directly link to heart health in common discourse.
It certainly does, while some associations for specific cardiovascular events like heart attacks and heart failure were somewhat attenuated after adjusting for age, sex, and smoking. The overall benefit for cardiovascular mortality remains strikingly clear. This suggests that a robust immune system fostered by a healthy thymus contributes significantly to preventing the ultimate fatal outcomes of heart disease, perhaps by better managing inflammation or fighting off latent infections that contribute to atherosclerosis.
That's a really important distinction. The reduction in mortality, even if the risk of events isn't quite as dramatically reduced after adjustments. It implies that a healthy thymus might help your body recover better or prevent the progression of cardiovascular disease to its most fatal stages. What about cancer, which is another major concern as we get older?
On the cancer front, the findings were equally significant. Better thymic health was linked to a 36% lower risk of developing lung cancer. The incidence of lung cancer was 3.4% in the high thymic health group versus 5.3% in the low thymic health group. Furthermore, deaths due to lung cancer were almost halved in those with better thymic function. This strongly suggests that a well-functioning thymus helps the immune system identify and eliminate nascent cancer cells before they can establish themselves.
That makes so much sense, because T cells are specifically designed to recognize and destroy abnormal cells, which is exactly what cancer cells are. So if your thymus is producing a diverse and robust army of T cells, they're more likely to catch those rogue cells early on. It's like having a better surveillance system in your body.
Exactly. And the implications go even further. In a separate but related study involving over 1,200 cancer patients who were receiving immunotherapy, a treatment that harnesses the body's own immune system to fight cancer, stronger thymic health was associated with a 37% lower risk of cancer progression, and a 44% lower risk of death. This is huge because it suggests the thymus plays a critical role in the effectiveness of these cutting-edge immune-based cancer treatments.
So, not only does a healthy thymus potentially prevent cancer, but it could also make our most advanced cancer treatments more effective. That's a double whammy. It means the thymus isn't just about initial immune defense, but also about the ongoing battle against diseases once they've taken root. This really redefines its importance at every stage of life.
It truly does. It elevates the thymus from a forgotten gland to a central regulator of immune-mediated aging and disease susceptibility. But to really put these findings into perspective, let's compare these risk reductions to the baseline risks for cardiovascular disease and cancer in the general population. This helps us grasp the absolute magnitude of what they're talking about.
That's a great idea because percentages can sometimes feel abstract without that context. What are we looking at in terms of typical risks for these major diseases? Give us the broad strokes so we can really appreciate the impact of a healthy thymus.
Okay, let's consider cardiovascular disease first. Heart disease remains the leading cause of death globally. In the US alone, one person dies every 34 seconds from CVD, with nearly 1 million deaths in 2023. Roughly 1 in 20 adults aged 20 and older have coronary artery disease. Key risk factors are well known: high blood pressure, high cholesterol, smoking, diabetes, obesity, and physical inactivity. Forecasts suggest the prevalence of total cardiovascular disease in U.S. adults will rise from 11.3% in 2020 to 15.0% by 2050.
So, these are incredibly widespread and impactful conditions. When you say someone has a 63% lower risk of cardiovascular death against a backdrop where CVD is a leading killer, that's not just a statistical curiosity, it's a profound health advantage. It means potentially adding years, even decades, of healthy life, which is what everyone hopes for.
Exactly. Now, for cancer, it's also a leading cause of death worldwide, with approximately 10 million deaths in 2020. Advancing age is the most significant risk factor for cancer overall. The lifetime risk of developing cancer was estimated at about 25% globally in 2020, meaning roughly 1 in 4 people will develop cancer. Incidence rates climb steadily with age, from fewer than 26 cases per 100,000 under age 20 to over 1,000 per 100,000 in those 60 and older.
So, again, we're talking about a disease that affects a huge portion of the population, especially as we get older. A 36% lower risk of lung cancer specifically is massive, given how prevalent and deadly lung cancer can be, and the boost to immunotherapy success is just incredible, offering a new dimension to fighting existing cancers. These numbers are really putting the thymus front and center in longevity research.
They absolutely do. These observed risk reductions are not just small percentage points, they represent significant shifts in an individual's long-term health trajectory. It truly highlights the potential impact of maintaining thymic health on overall longevity and disease prevention, making it a target for future interventions.
Before we dive into what this means for the future, I want to quickly address something that's always important to consider with major studies like this: the funding. Who supported this research? Because knowing the funding sources helps us understand the context and potential motivations behind the study.
That's an excellent point, Maya. It's always crucial to examine the funding. This research received support from a diverse array of prominent organizations, including the National Institutes of Health, or NIH, the European Research Council, the Deutsche Forschungsgemeinschaft, which is the German Research Foundation, the Lundbeck Foundation, the Novo Nordisk Foundation, and the Savverkseiger Jeppe Juul og Hustru Ovida Juul Research Stipend.
That's a very broad and reputable range of funding bodies, which is reassuring. It suggests a strong, independent scientific interest in these findings, rather than being tied to a single commercial entity. Okay, so we've established the significance of this research. Now let's steelman both sides, as we like to do. What's the strongest case for why this is such a big deal? A true paradigm shift.
The strongest case for significance is multifaceted. First, it fundamentally redefines the role of the thymus in adult health. It moves it from a neglected childhood organ to a central regulator of immune-mediated aging and disease susceptibility. This isn't just an incremental finding, it's a paradigm shift that could open entirely new avenues for understanding human health and disease, challenging decades of medical consensus.
That's huge. I mean, to completely flip the script on an organ's function throughout life is not something that happens every day in science. So it's not just about what the thymus does, but also about how we perceive and study the aging process itself, recognizing the immune system's constant battle against disease.
Exactly. Second, this AI driven imaging method for assessing thymic health could serve as a novel and powerful biomarker. Imagine being able to get a thymic health score from a routine CT scan that could tell you your personalized risk of all cause mortality, cardiovascular disease, and cancer. That's a game changer for predictive medicine and early intervention.
A new biomarker would be incredible. It could provide a clearer picture of an individual's immune resilience and their overall biological age, perhaps even more accurately than chronological age alone. And if we can identify individuals at higher risk, we can then tailor preventive strategies much more effectively.
And it goes further into treatment. The research suggests this score may also predict a patient's response to modern cancer immunotherapies. This could allow for more personalized and effective treatment strategies, directing precious and potent therapies to those most likely to benefit, and perhaps exploring alternative approaches for those less likely to respond.
That's a massive implication for oncology. Being able to predict who will respond best to immunotherapy could save lives, reduce unnecessary treatments, and optimize resources. It really underscores how intertwined our immune system is with our ability to fight off even the most advanced diseases.
Furthermore, the study identified a link between poorer thymic health and several modifiable lifestyle factors. We're talking about things like smoking, obesity, metabolic syndrome, and chronic inflammation. This is incredibly important because it suggests that lifestyle interventions, things we can actually control, could potentially improve thymic function and consequently overall health and longevity.
That's the hopeful part, isn't it? If it was purely genetic and unchangeable, it would be interesting but less empowering. But if our choices can positively influence this forgotten organ, then it opens up a whole new avenue for proactive health management and preventative medicine. It gives us agency.
Absolutely. And finally, by highlighting the thymus's critical role, these studies underscore its potential as a direct target for future preventive and regenerative strategies. Research into thymic regeneration is already an active area, exploring methods like stem cell therapies, thymus extracts, and hormonal interventions. This research gives that field a massive boost and a clear clinical target.
So, the significance is clear: a forgotten organ redefined, a new biomarker, improved personalized medicine, and new targets for intervention. But Alex, as with all cutting-edge science, there are always limitations and nuances to consider. What's the other side of the coin here? What are the caveats and areas where more research is needed?
That's an important perspective to maintain. Firstly, the AI-driven imaging method for assessing thymic health, while revolutionary, is not yet ready for routine clinical use. It requires further validation and development before it can be widely implemented in healthcare settings. So, while promising, it's not something you can ask your doctor for tomorrow.
That's a crucial point for managing expectations. It's exciting, but it's still in the research phase for practical application. We can't just walk into a clinic and expect a thymus checkup right now, even if the underlying science is compelling.
Exactly. Secondly, the researchers themselves have cautioned that their findings will need to be confirmed in future studies. While the cohorts used were impressively large and diverse, replication across different populations and study designs will strengthen the evidence and ensure the findings are generalizable across various demographics and health contexts.
That's standard scientific rigor. One major study, no matter how robust, isn't the final word. We need independent verification and replication to cement these findings as established medical fact. It's how science builds its knowledge base.
And thirdly, and critically, the primary studies are observational. This means they demonstrate strong associations between thymic health and outcomes rather than direct causation. While the researchers meticulously adjusted for many confounding factors like age, sex, smoking, and existing comorbidities, it's inherently challenging to definitively prove cause and effect in such studies.
So, is it possible that a healthy thymus is more of an indicator of overall good health rather than the direct cause of these improved outcomes? Like maybe people who maintain a healthy thymus also tend to have other healthy habits or genetic predispositions that are actually driving the longevity?
That's precisely the nuance. It remains to be fully elucidated whether poor thymic health directly causes these increased risks, or if it's a sensitive indicator of other underlying health issues that contribute to a weaker immune system and faster aging. It's likely a complex interplay, but the observational nature means we can't draw definitive causal arrows yet. More mechanistic studies are needed to unravel the precise pathways.
And immune aging itself is incredibly complex, isn't it? It's not just about one organ. So focusing solely on the thymus, while incredibly important, might not capture the full picture of immune decline and its impact on longevity. There are other players in the immune system that also age and contribute to immunosenescence.
You're absolutely right. While the thymus is now understood to be a central driver of immune aging, immunosenescence is a multifaceted process involving other immune cell types, inflammatory responses, and even changes in bone marrow function. So, while this research shines a bright light on the thymus, it's part of a larger, intricate puzzle.
That makes sense. It's a crucial piece, but not the only piece. And what about those regeneration strategies you mentioned? Are there any potential downsides or risks associated with trying to rejuvenate the thymus? Because messing with your immune system sounds like it could have unintended consequences.
Indeed, while promising strategies for thymic rejuvenation are still largely experimental and carry potential risks. For example, some approaches involve growth hormone and IGF-1, which can stimulate thymic activity. However, these factors have also been associated with an increased risk of certain cancers. So, thorough research into the long-term safety and efficacy of such interventions is absolutely essential before they could ever become widespread.
That's a critical cautionary note. We wouldn't want to solve one problem by inadvertently creating another. The immune system is a delicate balance, and boosting one aspect could throw off another, potentially leading to issues like autoimmunity, where the immune system starts attacking the body's own healthy tissues.
Precisely. Some experimental regeneration techniques in animal models or small human trials have shown complications like autoimmunity post-transplantation, or have yielded murky conclusions due to small sample sizes and a lack of proper controls. This reinforces the need for rigorous, well-designed clinical trials before any widespread application.
So, to summarize the nuances, it's early days for clinical application. The findings need further confirmation. It's observational rather than causal. Immune aging is complex, and regeneration strategies come with potential risks. But despite these caveats, it still feels like a monumental shift in our understanding of this organ.
It absolutely does. The sheer magnitude of the risk reductions observed: 50% lower all-cause mortality, 63% lower cardiovascular death, 36% lower lung cancer risk, even if observational, are difficult to ignore. This research has firmly placed the thymus at the forefront of longevity research and disease prevention, even as we acknowledge the path ahead for clinical translation is still long.
So, what does this mean for us? The average person right now, we can't get a thymic health score yet, and we certainly can't get thymic regeneration therapy. Is there anything we can take away from this that might influence our daily lives?
That's a very practical question, while direct interventions are still in the future. The fact that poorer thymic health was linked to modifiable lifestyle factors like smoking, obesity, metabolic syndrome, and chronic inflammation is a huge takeaway. It reinforces the importance of foundational health principles.
So, essentially, all the things we already know are good for us: a healthy diet, regular exercise, maintaining a healthy weight, and avoiding smoking aren't just good for our heart or general well being, but they might also be directly supporting the health and function of our thymus, and by extension, our immune system and longevity.
Exactly. If a healthier thymus is linked to these positive outcomes, and if poor thymic health is linked to poor lifestyle, then it suggests that by adopting those healthy habits, we might be indirectly supporting our thymic function. It adds another layer of motivation to prioritize a healthy lifestyle, knowing it could be directly impacting this crucial, previously overlooked organ.
It's like finding a hidden lever for longevity that we didn't even know existed. and it turns out that lever is connected to the same healthy habits we've always been told to adopt. It provides a deeper scientific justification for living well, beyond just feeling good in the short term.
It gives us a tangible biological mechanism to connect those dots. Maya, this research sparks so much potential for future studies. Imagine screening for thymic health in midlife, identifying individuals at high risk, and then intervening with targeted lifestyle changes or eventually more direct therapies. The implications for personalized medicine and preventative health are enormous.
It truly opens up a whole new frontier in understanding healthy aging. It's no longer just about managing chronic diseases as they arise, but about proactively supporting our immune system's core engine, the thymus, to prevent them from taking hold in the first place. This is definitely one of those topics that makes you want to immediately go out and eat more vegetables.
I completely agree. This research reminds us that even after decades of medical science, there are still fundamental biological mysteries in our own bodies waiting to be uncovered, and when they are, they can completely reshape our understanding of health and longevity. The thymus, once forgotten, is now undeniably back in the spotlight.
And what a comeback it's making, the organ you forgot about controlling how long you live. It's a powerful and exciting new chapter in the story of human health. Thank you for shedding light on this incredible research, Alex. This has been truly eye-opening.
My pleasure, Maya. It's a testament to the fact that science is always evolving, and what we know nothing about today could be the key to breakthroughs tomorrow.